In today's video, we're going to start Unit 13, which is on statistics. We're going to start with Lesson 1, which is on combinations and permutations. I've already written some of the material on this sheet, but I'm going to read it to you. So both combinations and permutations are picking R items from a group of N. A combination, more specifically, is an arrangement or listing in which order does not matter. So a permutation is when a group of objects or people are arranged in a certain order. So back to combinations for a minute. So in a combination, order does not matter. So being chosen first doesn't give you a different outcome than being chosen second. Whereas with a permutation, being chosen first gives you a different outcome than being chosen second. So some key words here for combinations are order does not matter. But for a permutation, order matters. So let's go over a few examples here of each, and then we'll look at the rest of this information. So for a combination, some examples could be like a raffle. The order that things are chosen doesn't matter, slash lottery, but again, when order doesn't matter. It could be choosing a 7-person prom committee. That the order that they're chosen doesn't matter, just they're all part of the same committee. Or choosing 5 cards from a deck. The formula looks like this. N choose R, so the total in the group, and choose the amount that you're choosing. And this is a formula that you can do it by hand. So this right here, the N with the exclamation point, is called N factorial. And what that means is like for instance, if I say 6 factorial, that means 6 times 5 times 4 times 3 times 2 times 1. So it's the number multiplied by everything below it. So it's N factorial over R factorial times N minus R factorial. In the calculator, you can figure this out by hitting the math button, then PRB, standing for probability, and then you put your N number, and then your R number. So option 3, is going to give you the N, choose R. So for examples of a permutation, seating chart, definitely matters where you sit in a room. Batting lineup in baseball. And running in a race where prizes are given for first, second, and third. So the formula looks very similar to the combination formula, but for permutations, it's NPR. So N factorial and then N minus R factorial. And in the calculator, it's going to be the math button, the PRB button, or option, and then option number 2. So let's go over some practice problems here. So the first thing you're going to want to do is decide what type. Oh, and when you do in the calculator these steps, you put in your N number first, then hit math probability option 3, and then you put in the R. Same thing for the permutation. Sorry about that, forgot to mention that. All right, so on to our example problems. So we got to first decide what type of problem it is, whether it's a permutation or a combination, and then we're going to solve them. And we're going to solve all of these by hand, but we could definitely use our calculator if we needed to. So how many arrangements are there to assign 15 runners of a race into first, second, and third place. So this is an example of a permutation. All right. So we have our n is 15 because that's the total, and then the r is going to be 3. So 15 p 3. So our formula says we do n factorial, so 15 factorial over 15 minus 3 factorial. So 15 minus 3 is 12. So you have 15 times 14 times 13 times 12, and then we can keep going. I'm just going to call it 12 factorial over 12 factorial. So these are going to cancel, leaving you with 15 times 14 times 13, which is 2,730. All right. So our next one says, how many combinations of 4 letters can be made from A, B, C, D, E, F, G? It doesn't say that they have to make a word or anything, so this is an example of a combination. So we have, if we're working with A through G, that is 7 options total for our n, and we're going to choose 4 of them. So our formula, we're going to have 7 factorial over 4 factorial times 7 minus 4 factorial. So 7 factorial, 7 times 6 times 5 times 4 factorial. I stopped at 4 factorial because I saw there's also a 4 factorial down below. So those two things are going to cancel. All right, and so then I'm left with 7 times 6 times 5 over 3 times 2 times 1, which becomes 210 over 6, which is 35. All right. There are 16 Buffalo Bills games in a regular season. You and your friends have enough money to attend 4 games. How many combinations of games can you pick? So the question kind of gives it away. This is an example of a combination problem. So you're going to have 16, choose 4. So that's going to be 16 factorial over 4 factorial times 16 minus 4 factorial. All right, so that's 16 times 15 times 14 times 13 times 12 factorial. I'm going to stop there because I know what 16 minus 4 is. That's 12 factorial. So I can cancel those. So then I'm left with 16 times 15 times 14 times 13 over 4 times 3 times 2 times 1, which is going to be 43,680 divided by 24, which is going to give you 1,820. All right. Next one, how many combinations of 6 students can be selected from a class of 29? Again, it gives it away with a combination. All right, so we have 29 and we're choosing 6. Whoops, hold on one second. Sorry about that. Got too close to the edge of the table there. We're trying to do a combination here. So that's going to be 29 factorial over 6 factorial times 29 minus 6 factorial. So 29 times 28 times 27 times 26 times 25 times 24 times 23. I'm going to stop there, factorial. Because we have 6 factorial here times 23 factorial. So the 23 factorials cancel, leaving us with the following. Hold on one second. So that's 342,014,400, and then we're going to divide that by 720 to get 475,020 options there. All right, so there are 8 Harry Potter movies. You and your friends decide to pick 3 of them for your Harry Potter weekend movie marathon. How many different groups of 3 can you pick? Now, at first glance, you might think, oh, it doesn't matter what order you watch them in, but you want to watch them sequentially. So we're going to say this is a permutation. All right, so you have 8 movies, and you're going to pick 3 of them. So our formula, we're going to have 8 factorial over 8 minus 3 factorial, so that's going to be 8 times 7 times 6 times 5 factorial, which is what 8 minus 3 is. So those go away, so we just have to do 8 times 7 times 6, which is 336. All right, and that is, sorry it's so fuzzy there, I'm not sure why it's being so fuzzy to end it off. But that is the end of the notes.